Hello, it's me, and I've had some requests to go over the circle 4x4. I guess it's called a crazy 4x4. Now, I really enjoy these puzzles because there was a time where I really got into these circle puzzles. I was pretty fascinated with that. The fact that you've got yourself a 4x4 puzzle standard, but you've got this added challenge of having the circle in here, and that these circles participate in the scramble like that. Got a circle 3x3, a couple other crazy puzzles, but this one's a nice one. It's bandaged on all sides. What that means is all of the centers are held fixed with this. Now, and this one over here, there's three types. There's the type 1 where you have the center that just encompasses you've got the circle that just encompasses the center over here. So it slices through here, leaving part of the center by itself and the rest of the centers as bandaged like that. So this is one. Type 2 is it extends so that it encompasses the entire center and slices into the edges over here. So that adds to the challenge as well, because not only do you have to deal with what's going on here, you've now got these extra pieces that you have to deal with also. So the scramble encompasses that as well. And then just when you thought you were safe, they come out with type 3. Turns out you were safe all along because it doesn't really change the way that the solve is too much. But as you can see over here, the circles actually extended well beyond the edges and slice into the corners. So this is just in the center, this includes the edges, and this encompasses the corner. What I'm going to do actually, I'm going to do two restrictions. First off, I did want to point out that sometime early on, one of these little tiles came out. It's annoying, I know, but I can't find it. So I'm going to have to be doing this with this out here. So anybody that bothers, like me, well, forgive me, but I don't know where that is. Anyone knows where I can pick up an extra one? Let me know. But anyway, if you know how to solve this, then you know how to solve this. And if you know how to solve this, you know how to solve this. So I bring these out more just to kind of demonstrate things. But I'm just going to go over this guy over here when solving this. Now, how does this differ from a usual 4x4? Well, my contention is that this in some ways is easier because it avoids some of the parodies that you're going to get with the 4x4. And of course, in some ways it's harder because it encompasses the strategies of different puzzles. To solve this, you need to know how to solve, well, a standard 4x4. But you're also going to need to know strategies and concepts of solving a 2x2x4, because ultimately these pieces are going to act like a cuboid. Center reduction is done very different than you would do with the standard 4x4. So let's talk about some of the concepts behind this puzzle, and it'll make some of the strategies make a little bit more sense. Now, we need to bear in mind that when we scramble a puzzle, there's a degree of consistency with that scramble and a degree of association between pieces. For instance, if you take a 3x3, to scramble a 3x3 doesn't mean that everything is just moved around randomly. If you take a 3x3, completely disassemble it, then put it all back together again in a scrambled form, you won't necessarily be able to solve it in that form. And a true scramble of any puzzle doesn't really work like that. That every pattern that you do, every movement that you do, there's an association between the different pieces with each other. So even in a fully scrambled form, that association is maintained, and that there's restrictions in how much you can scramble a puzzle, which causes some ease in the solve, because all these algorithms are based on the fact, and all the laws of the cubes are based on the fact, that there is an inherent consistency and an association with each piece. Certain swaps you can do, certain swaps you can't do. You cannot flip just one piece, you cannot do just one swap. The reason for that is that there's a pattern to the scramble and an association with the pieces that make the solve and make the algorithms work. Well, why do I mention that? I mention that because although this looks like it's a more complex puzzle than a 4x4, although it looks like there's more pieces to deal with, because I've got to deal with these different centers, but I also have to deal with these edges over here, and they're all different from each other. In other words, as soon as I separate these out, suddenly I've got to deal with this independently from this. And not to mention, I've got these corners that I have to deal with as well. Even though it appears that way, the fact is there is an internal association with these pieces, despite the fact that I have a full scramble. So I'm going to let you know what I mean as I'm doing this. So I'm going to go ahead and do a scramble of this guy. Now, this is kind of an older, more rickety puzzle, but as you can see as I'm scrambling this, it looks like things are just kind of moving randomly. The fact that all of these centers don't move, the fact that they are held constant means that there's a pattern that I go through as I'm scrambling this puzzle. And that pattern is never broken, and that pattern encompasses a relationship between these pieces. So without any further ado, I'm going to go ahead and continue with that. Hocus pocus. Okay, what I really like about this puzzle is it looks pretty impressive when scrambled. You can show someone this and say, so, you think this guy was tough, huh? Well, take a look at this. So much more complexity to this puzzle. I can turn these around. I've got to get everything back in. And there's obviously a lot more that you have to deal with in order to do that. Well, there's a couple of important differences between the circle 4x4 and an actual 4x4. One difference, of course, is the fact that this is always staying put. And this did stay put the entire time. This one doesn't. When you scramble an actual 4x4, all of these center pieces are not really attached to the core, so to speak. They're free to, well, if they are attached, they're attached in a way where they're free to move around, which means there's no specific association between these. I could flip these two cores if I wanted to. Of course, if I did that, I wouldn't be able to put edges in that made sense, but I could do that. Here I can't. I can't go through that process. I can move things around, but I have to be pretty specific in terms of what I do. I cannot do clean swaps, and here's the reason why. The way that this puzzle is because of the bandaging that happens with this. If you notice, there are three corners, three sets of three centers rather, that you never separate from each other. These two can separate quite easily. See? And these can separate quite easily as well. But notice, no matter what I do, I cannot get these three centerpieces to separate from each other. If I move it like this is still in association with these guys here. How about here? It's the same kind of concept. No matter what I move, if I'm just moving the edges, the centers don't move at all. So every center is associated with each other. But if I move it from here, well, these three are moving with each other. If I move it here, these three are moving with each other. So even though these guys may not actually be physically attached to each other, the bandaging of this puzzle functionally makes it in a situation where I'm never able to separate these pieces out. What that means is that the centers of this puzzle does not function like true 4x4 centers that can be moved around independently of each other. The center here acts as a 2x2x2, exactly like a 2x2x2, as exemplified by this big softy puzzle over here. Kind of an interesting thing here. But in any case, as shown by this, and I believe this is the correct color configuration, this red, white, and blue side here, you can find that here too. Here's red, white, and blue. And I'll never be able to take that away. And that was restriction number one. There's three, which are going to be very useful for the solve. So what I'm going to do is a 2x2 solve. We'll start off with a green side over here. Green, find another green over here, put it in the right place. So I'm not going to go into the details of how to do a 2x2 solve. I have to assume that you know how to do it, but basically I'm putting in the first side over here. Here's the green side over here. This comes up over here, so I'm just kind of doing the cross. But notice, I can do this. I wouldn't be able to do that with this puzzle because there wouldn't be an association between these three because they're not connected. These, although they're not physically connected, they're functionally connected by the way that the centers are bandaged, the way that they're held in check. So we have the green side with these in the proper place. So we turn it upside down and just continue to solve over here. The way I do it is I find one that's right side up. In this case, I've got two. Sorry about that. These are automatically up here, so these are fine over here. Are these in? And the answer is no. This red needs to come here. So I'm not looking at these as different pieces. I'm looking at this as one piece here. This is red, blue, and white, which needs to be over here, red, blue, and white. So these two need to swap, so I'll just do a corner swap. 2R, U, 2R, UI, 2R. Turn the puzzle here, 2R, UI, 2R, U, 2R. And then turn this back. Now, to those who might not know what I'm doing the solve of a 2x2. If you don't know how to do the solve of a 2x2, let me know and I can point you in that direction. But what's important for you to understand is that what I'm doing is I'm just focusing on these center pieces here, and I'm showing you that these center pieces function like a 2x2. These corner pieces here, 1, 2, 3 pieces here together make up these three over here. And again, If you don't know how to do 2x2 solve, let me know, I can point you in that direction. So center pieces are like this. Then last step is all of these pieces are oriented correctly. Again, pretend these are the same piece, so we just have to functionally rotate it. So this will come here, this will come here, and this will come here. I'm not doing a three-way swap with this. That's not what this is at all. This is looking at this as one piece that just needs to be rotated. So to do that, if everything is in the right place, quote unquote, if these three pieces collectively, which are being called like this piece, are in the right place, they just have to be rotated. So is this one over here. Then I do my RI, DI, RDs to make that happen. RI, DI, RD, RI, DI, RD. Now you can see that this is in. Don't worry about what's going on down here. Move this to the side. RI, DI, RD, RI, DI, RD, RI, DI, RD, RI, DI, R. Okay, so what you're going to find is these are all in. And again, that was 2x2 solve. Upon request, if you don't know what I just did, let me know, and I'll do a corollary video of how to do a 2x2 solve. So moving on with this, the next part in our reductive strategy is I don't want to do these edges together. What I'm going to want to do is get these guys in. So how am I going to do that? Well, this is where we get to our second association. Just like these three pieces are associated with each other and can be looked at as one piece, we can actually do that with these edges over here. So the edges that are within the circle here, notice if you take this piece and this piece, you will find that these two can never be separate from each other. It's like they're connected. I don't want you to be confused with that. Okay, so what I just did is if I move this, this stays the same, this stays the same. They're not actually physically connected. This stays the same. If I turn this over here, because of the bandaging, they still stay the same. If I turn it like this, these guys move with each other. If I turn it like this, or if I turn it like this, they move together, which means there is no move that I can do to make these two edge pieces separate from each other. I could separate these guys out, right? Just separate this from this. But because of that, when I scrambled this, I never took away the association of these two pieces. So they're still associated with each other. So green and orange, you're going to find that there's a green and orange next to each other where that's going to go. So with that said, I'm going to look at these as though they were the same, as though they were connected to each other, even if they're not physically connected, just like these guys were. But not just these two, all of the ones. All of these circular edges where the small ends are facing each other are sort of connected in a functional way. With that said, then I can do algorithms that have to do with not just moving this separately and this, but an algorithm that flips these and moves these should I need to do that. And it's just a matter of finding that. With that said, I'm going to try to get all of the green ones in here appropriately. If I do this correctly though, if this and this are connected with each other, obviously this isn't in the right place, to put all of these in mean I'll be putting all of these in as well. So that decreases my work by about a half, because now I don't need to focus on them individually. So although you can say, oh good, this is in, the answer is it's really not, because this is the wrong one. Because this is the wrong one and these two are connected, this piece collectively needs to be actually here. Same thing with this. This is the wrong one here as well. So, how do we do it? Well, what I'm really looking for is I'm really looking for a situation where I get these pieces, the green pieces that are joined here, and I put them up here. Once they're up here, then I'm going to try to flip them into place. So how am I going to do that? Well, if you're in a situation where you don't have any up here, as I don't, what I'm going to want to do is start picking pieces to make that happen. The easiest way to do that is if it's down over here. What I'm going to do is I'm going to go do a 2R, or in this case a 2L. So if it's on this side, 2L, so it's over here. Then I'm going to bump it out of the way. So I'll just do a U and 2L. All right, that 2LU, 2L, put it over to here. So that's if it's down over here. Do that quick commutator. Now you don't have to memorize that. I would encourage you not to. You can visualize what's going on. You just took this, move it over here, then bump it to the side and move it back down. But some people are requiring algorithms, so there you have it. Once it's here, then what do I do? Well, what I need to do is this collectively needs to come here and here. So how do I do that? Well, I'm going to utilize an algorithm that we already know that has to do with something that moves edges around. So in trying to find something that can move corners around and orient them around, let's take a look at actually what happens with the 4x4. The one that I know of that can take, not corners, but edges and move them around is the one that goes R, U, R, I, U, R, 2, U, R, I. Now as you recall, what that's going to do is that's going to take these edges, this one stays the same, it's just going to move these around. What if I were to do the same thing, but I did it with this as my R move and this as my U move? So what I'm going to do is, let's see what happens. We'll go R, U, R, I, U, R, 2U, RI. Same thing. Now something to notice, doesn't matter what happened with everything else, but something to notice is what happened with these edges here. What happened is that these collectively came over to here and flipped. But if I just cared about, say, the edges here, because I'm correlating that with these edges over here, if I just correlated with what was happening with, say, this over here, this one was a blue and a orange. This came over here and flipped. So in essence, what happened is that the color that was here, which is yellow, or orange rather, flipped up to over here, and the color that was here flipped down over to here. So what's going to happen is that the piece that was here will come over to here and flip. Well, that's kind of what I want to do. If we're to look at this and we correlated this with, say, a piece over here, this piece over here, and I did that algorithm, I can make it flip, which means whatever color was here will end up over here. So if I were to try that and coordinate it like that, then this color would end up here and this color would end up here. But that's not what I want to do. I want to do just the opposite. So instead of on the right side, if I were to, say, move this, well, I'll keep it on the right side, but we'll put it on the left, say over, well, over here. What would happen is if I were to do just the opposite, so bear with me, instead of doing it RU, RU, R2U, RI, if I did it on the left side, what would happen is that the color that's on this side, in this case it was the color that was on this side, so here's your front face, the color that was on the right, if I did the same thing but on the left, the color that was here would end up over here, which means that this would end up here, and this would end up here, which is what I wanted. So I'm going to use the same algorithm, but in this case, bear with me, it's going to be a left-sided version and not the right-sided version. Should take this collective edge piece, which is these two pieces together making up this collective edge piece, and flip it like this. So that's the theory. So I'm going to do the left-handed version of this, which is going to be Li, Ui, L, Ui, Li, 2U, L. So what that did is, in essence, it put this here and this here. One algorithm, two pieces that are kind of connected like that. So it worked, and that's what we're going to do. The whole key here now is to remember if it's on the left side or on the right side. If it's on the left side, angle it to where the one that you have in front of you, put it to where the color that you want up here, in this case I did green, is on either the left or the right. And just plan it out to where this color is the one that goes to the center over here. So let's see how we can maybe move some others. We don't have any other greens here or down here, so we have to get, let's say it's over here. How are we going to move this up? Well, let's kind of plan this out. We know that if we move this, this will put this in the right position. So if I were to move this up here and then turn this like so, then I can move that up there. If you want an algorithm to that, fine, just go like L, Ui, L. Instead of 2L, Ui, 2L, it's L, Ui, L. So that's over here. And you won't mess up anything else. So let's move this so that it's at the side, either the left or the right, but we want this white to go to a white center. So let's line this up to where just where this green is hovering over is where the center is. So if we do that algorithm again, left-sided version, this will flip up here and this will come down here. Same algorithm, Li, Ui, L, UI, LI, 2U, L. And there it is. So we just keep following that around. Again, the trick is moving things up without destroying what you have here. Now, if you find that they're over here, well, that's going to be a little bit of a problem getting it out. Well, maybe not so much. Let's say you wanted to pull this one out. Well, we could push this up here and push it out like this, but the problem with that is I'm going to end up pushing this one out. So if you want to push this out, it has to be over a piece that's not in an empty set. Well, I can't just turn it into position like this, so I'm going to have to move it from the middle. So I'm going to move this from the middle until this is above it. So what I'm going to do is move this up like this, turn this out of the way, move this down. And now it's quite easy to just move this middle back over here. So now this is where it needs to be. So we'll do the same kind of thing, only this time this is on the right side. So this is hovering over the center where this is supposed to go, and this is in front of us. And understand that when we do this, the green, remember the color that you want up here is always either going to be on the right or the left. This one, which is attached to this, is going to end up going to the side that this green is over. In this case, it's red. So doing the right-sided version, this will come up here and this will come down here, flipping the same way that this did. And that's going to be R, U, RI, U, R, 2U, RI, and there it is. So we're doing well. And we're just going to keep continuing with that. Here's another example. I don't want to move it up from here, so I'm going to turn this like so, because I have to make sure that it's directly over something that's not in. Move it up. Now when I bring it across, I don't want to move it this way because I'll end up moving it down here. So make sure you move it out of the way from the area that's actually going to turn, which is over here, and then bring it down. And this can come back. And you're not going to destroy, if you're careful, everything that you did. And even if you did, who cares? You can easily bring it back in. So now this green is going to end up on the left side, but I want the green to be hovering over the same color center as this one that it's attached to, which is going to be red. So we'll just move it here. It's hovering over the red. And now go ahead and do that algorithm. Left-sided version, LI, UI, L, UI, LI, 2U, L, and there it is. So remember, as we're putting these in, we're starting to solve these guys as well. So everything is taken out of here. What about, well, here's one here that we can use. This is going to be on this side, but we don't want to do it here because this will end up down here. So we have to hover the green over the center, same colored center as the piece that's going to be in front of you. R, U, RI, U, R, 2U, RI, and there that is. Anything else up here? This one. So we can easily cruise through this. Green hovering over the white center, which is with the attached colored piece to the green one. R, U, RI, U, R, 2U, RI, and that's good. So we're down to the last two. Well, they're on this side. So we saw how to get it out of here. We saw how to get it out of here. Now, how do we get them out of here or here? Well, just kind of visualize that again. You're going to be, I think we also saw how to get it out of here too. To get it out of here, it's the same kind of thing. You're going to be moving it up and then moving this over. But again, be careful, because if you're moving it and you have a green one that's in, you're going to bump it out. So before we move this, we have to move it to a side where we don't have a green one up here, because we don't care if we bump that out. So move it up to an R, U, RI, and then we can move this back. So now this is up here. And again, if you mess up on these, doesn't matter. You just get it back in easily. The priority is putting it up in this layer just below that so it can act as an edge piece, collectively an edge piece that just needs to be flipped. And that's exactly what you're doing. So hold this to the right, but it's got to hover over the center that this belongs to. In this case, over here, R, U, RI, U, R, 2U, RI. So you're taking advantage of the consistency of the bandaging of this puzzle, making it actually a lot simpler than you might think. Okay, this one, so we have a situation where we have to somehow bring this up. Oh, actually, we can do that here. So we can go turn this up over here, turn, and bring it down. Now, if we did have a situation where none of them correlated, then that's fine. You can bump one of these out. You're still going to keep it in the same level. So if you run into a bind, go ahead and bump another one out. You can just put that one back in later. Okay, once again, hold this to the side. These two are connected. This is hovering above the color that this one is that's in front of you. Left-sided version, Li, Ui, L, Ui, Li, 2U, L. Okay, so we're good. Not only did we solve these, but we put these in as well. So we have this almost completely reduced, but what about these guys? Well, this was the part of it that this didn't have. So you solve this exactly the same way, but you use these guys instead. But we didn't have the corner pieces within the circle. We're going to come back to that because that'll get into our third association of different puzzles, of different pieces rather. Instead, what we're going to do is we're just going to do the same thing on the blue side. And we're going to go through this and see if we can't come up across situations that we might not have gone over. But anyway, these two pieces are connected. So let's hover them over the proper place, which in this case is going to be here. This blue is hovering over the yellow, which is the piece that it's attached to. Put this to the side, not on the front side, in this case the right. And although we have a piece here, you can see it's not the right piece, edge piece. R, U, R, I, U, R, 2U, R, I, and that's in, and that's good. Anything else up here? Yeah, this one. So this is already in the proper configuration. This is not. R, U, R, I, U, R, 2U, R, I. So darn simple. This over here, hover this over the right places. R, U, R, I, U, R, 2U, R, I. Easy as pie. All right, so there's no other blues here. What about this one? Well, let's bump this one out. Move this twice here. So again, we have this here. 2L, U, 2L. Pretty simple. You're not going to mess any of these guys up either. All right, so this will come over to here. Well, actually here, so that these guys can flip. Just remember, wherever the blue is, or whatever the color on the top is, which is always going to be either to the right or the left, that's what's going to flip to the top. So this is going to flip to the top over here. This is going to come down here. Li, Ui, L, Ui, Li, 2U, and L. So we're cooking. What else we got? Ah, this is already in place. Very good. And now right-sided version. Keep this to the right off of the front side so it can flip where it needs to be, and this comes down. R, U, R, I, U, R, 2U, R, I. We're good. Anything else? We got this. 2R, rather 2L, U, 2L. And we'll put this in the proper place. All right, hover this over the color where this is supposed to be. Li, Ui, L, Ui, Li, 2U, L. Okay, okay, now we're doing well. So these are all okay here. Good, good, good. And these are all okay there as well. Okay.